what we're going to have a look at in these lessons is 3 laws of exponents and then 1 definition of exponents. Basically, what we're going to have a look at are 4 very important concepts that we need to work with when working with exponents. So the first thing I just want to touch on is, what is an exponent? What are we dealing with when we're working with exponents? Just so that we actually understand what it is that we're going to see in front of us. And then we'll start chatting about these laws and these definitions that we need to know. Remember, as Yolanda said, take screenshots as we go along. I will always try and wait and pause for a few seconds so that you can take a screenshot, and I will remind you. But remember, once I've put the notes down and I say, okay, take your screenshots, remember to take your screenshots. If you don't know how to take a screenshot, just take a photo of the screen with your phone, and then at least you've got a picture of it. Alrighty. So the first thing we're going to chat about is what actually is an exponent. So when we're talking about exponents, essentially we're talking about a number with a power attached to it. And so you can see here, I've given you an example of 5 to the power 2. Now this number is made up of 2 parts. We've got one part, the 5, which is our base number. And we've got a second part, which is the small little number at the top, which is our exponent number. And essentially what this value tells me is the number of times I'm multiplying the base. So the exponent tells us how many times we multiply the base. Okay, so in this case, this is telling me to multiply the base of 5 twice. Maybe I should write that down properly. Multiply 5 2 times or twice. And so this 5 to the power of 2 is asking me to say 5 times 5. And as Tyler's put on the chat there, that would be 25. But an exponent has the job of telling me how many times I'm multiplying a specific value. It can be a variable, it can be a number, but it is telling me how many times I'm multiplying each unique value in my sum. So if we go and have a look at some of the examples that I have put down here on the side, our first example that we have here is 5 times 5 times 5. And so what I want to do is I want to write that in an exponential form. And so what I need to ask myself is, how many times am I multiplying the number 5? Well, I can see that I'm multiplying this 3 times. And so if I want to write this as an exponent, this would be 5 to the power of 3, because I'm multiplying that base 5 3 times. If I look at my second example here, where I've got all these 2's listed, I can see that I've got 4 2's, so I'm multiplying 2 4 times. And so in exponential form, or if I want to write this as an exponent, I am multiplying 2 4 times. I've got 2 to the power 4. Now, what we need to bear in mind is that we don't always need to be using the same numbers. But what that means is the second I start using different numbers, or when my bases are different, I need to consider them separately. So if we have a look at this third example, I can see that I've got 3 2's being multiplied together. So I'm multiplying 2 3 times. But then I'm also multiplying 3 twice. So I've got 2 different numbers that I'm multiplying here. And so when I have a situation like that, I can still write this as an exponent. I'm multiplying 2 3 times, and I'm multiplying 3 2 times. Now these are still being multiplied. That is the operation that's happening between these 2 numbers. So I've still got a multiplication, but I can condense it, or I can simplify it into an exponential form for myself. And so again, the exponent tells me how many times I'm multiplying a number or a value. Now this applies with variables as well. Just because we're working with variables, it doesn't change the way exponents work. Here I can see I've got x times x times x times x. So I am multiplying x 4 times, which means that I could write this as x to the power 4 to tell me that I am multiplying x 4 times. And the same sort of idea goes then with variables. If you are multiplying different variables, you just group them together according to the same bases or the same values. So here I've got x multiplied twice, and I've got y multiplied 4 times. And so if I want to write this in exponent form or exponential form, I've got x to the power 2 because I'm multiplying x twice, and y to the power 4 because I'm multiplying y 4 times. And so this is essentially what exponents are, guys. They tell us that, excuse me, we are multiplying a specific value however many times or a specific number of times. And so whenever you see this exponent, so whenever you see this little number attached at the top of another value, at the top of a base, that is the information it is giving you. So in today's lesson, what we're going to chat about is what we call the first law of exponents, which deals with multiplication. And essentially through these examples, we've actually already discussed this, but we're going to put it in a sort of sentence now for ourselves. So today we're looking at our first law of exponents, and that is going to deal with multiplication. Let's hope I can spell multiplication. Alrighty, so at this point, I'm going to ask if you want to raise your hand, or you can put it in the chat. Does anyone know what the first law of exponents is? And if you don't worry. Obviously, we are going to do it. If you haven't done exponents yet, that's absolutely fine. Oh, no one. All right, cool, guys. So this is quite exciting. It means that we're all starting exponents at the same time, which is awesome. Our first law of exponents says that when we are multiplying the same bases, when we multiply the same bases to write it, our answer, or to write it in exponential form, we just add the exponents. And I'll explain what I mean now. Okay, so if we have a look, say, for example, at this first example that we looked at, we had 5 times 5 times 5. So if I want to simplify this and I want to write this as one base with an exponent, my law tells me that when I multiply, and that's what I'm doing here, I'm multiplying 5 times 5 times 5, what I need to do is I need to add the exponents. Now, it's very important for us to remember that any number, if I don't have an exponent written with it, does have an exponent of 1. And so this law is telling me that if I want to simplify this, I would now say 5 to the power of, and I would add these exponents here. So 1 plus 1 plus 1, which gives me 5 to the power 3. Now we can already see that this is true because we did the first example. We said that 5 times 5 times 5 is 5 to the power 3. And that's what we've written down here. So whenever we are multiplying the same bases, and that's very, very important, it needs to be the same bases, we just go and add the exponents. Sorry, we've got some weird colors going on here. Right, so when we multiply the same bases, we add the exponents. Any number that doesn't have an exponent attached to it does actually have an exponent of 1. Alrighty, so Relay, well done. Sorry, I don't know why your message come through on the chat, but very nicely done. When we're multiplying two exponential values with the same base, we just add the exponents. Right, we are going to practice this. I know this is quite a bit of information all on one screen. So take a screenshot and we're going to practice this first law. We're going to put into practice this first law of exponents through some examples here. So I'll give you a second to take those screenshots. And guys, these laws that we're going to do and these rules that we're going to do, you're going to need to remember basically all the way up until matric if you plan on doing maths up until matric. And so as we write these down, you're going to see that in each lesson, there's going to be a little rainbow block like this one over here. And the rainbow block is going to deal with the law or the rule for the lesson. And so I would write these all down, maybe even on a separate piece of paper, so that by the end of our exponent section, you've almost got like a cheat sheet or an information sheet with all of your exponent laws that you can then apply. Obviously, you don't have to do it like that. It's completely up to you how you choose to take your notes. But everything in the rainbow blocks that we're going to do in our lesson is going to be our rules that we need to know for exponents. All right, I'm hoping we've all got screenshots. I'm going to give you 3 seconds, and then we're going to have a look at some examples. All righty. Oops. So let's have a look at some nice, easy examples to start off with. Of course, it's going to fight with me, so we're just going to... Right, there we go. So guys, just ignore example B for now. We'll get to example B. Let's just have a look at example A. Now, the way I'm going to show you how to do this, I wouldn't recommend doing this for every type of question like this. I'm just going to show you this so you understand why we get the answer. But obviously, you just apply your law and you can get your answer. So here we've got x to the power 2 or x squared multiplied by x to the power 3 or x cubed. Now we know that because these bases are exactly the same, I could just add the exponents, and we can do that. That's absolutely fine. But I want you to see why that is the case. So if we have a look at the x squared, that is telling me that I am multiplying x twice. And if I have a look at the x cubed, that is telling me that I'm multiplying x 3 times. And so essentially, when I want to, when I'm wanting to simplify exponential expressions, what I'm wanting to do is combine all the same bases together with one exponent. And so this we can clearly see tells me that I am multiplying x 5 times. And so my final simplified answer needs to reflect that. And so we know that we would have x to the power 5 to explain that we're multiplying x 5 times. Now, again, I would not go and expand. So this method here is expanding the original question. I wouldn't do that. The reason I wouldn't do that is because sometimes we can give you quite big exponents. So I could have said x to the power 20 times x to the power 30. You don't want to write out 20 x's and 30 x's. But this is why we have got our rule that we can apply. So our rule tells us that all we need to do is we need to add these exponents. So we would say x to the power 2 plus 3. And we know that 2 plus 3 is x to the power 5. You can see it gave me exactly the same answers if I expanded. So the methods both end up at the same place. But knowing your rule, knowing your law means that you can do it much faster. Now, you don't need to show this step over here. So you don't need to show the 2 plus 3. You are welcome to go straight to your answer. I'm just going to write it down so that you can see very clearly why I'm getting the answers I'm getting. So here, because we had the same basis of x, we could just go and add the exponents. So I'm just going to add a little note for ourselves here. Same bases. Therefore, we can add our exponents. All right, so if we have a look at something like question 2, we need to apply the same thing. Now, remember guys, when we are multiplying, we can always apply SNV. Now, if any of you have forgotten what SNV is, I'll write it out for you, so don't stress. So SNV represents signs, numbers, and variables. Basically, if you do your multiplication or your division in 3 steps, you will correctly multiply or divide anything that you're working with. So if we look at question B and we start with the signs, this is a positive 2x squared, and this is a positive 4x. So both of these terms are positive, which means a positive times a positive is a positive. So my sign is sorted for me. I know that my answer is going to be positive. I've dealt with that. Then I move on to the numbers. Now, very importantly, when we're talking about numbers, we're talking about the coefficients. So we're talking about the numbers, coefficients. We're talking about the numbers in front of the variables. So here our numbers are, let's just get a little highlighter. Here our numbers are 2, and the number in front of x, which we know is 1. And all I want to do is multiply those two together. So I would say 2 times 1, and I get the product 2. So I've dealt with my numbers. And then I move on to my variables. Now, this is where I check for my same bases. Here, I've got the base x and the base x. And because I've got the same bases, I can add my exponents. And so I've got 2x to the power 2 plus 4, which therefore gives me a simplified answer of 2x to the power 6. Now, again, you don't have to show the plus or the adding of the exponents. That's not necessary. You obviously are more than welcome to do it. You don't need to, but you can. And so as long as we remember SNV, as long as we remember that if it's the same basis, we can add the exponents, we are able to simplify our expressions. So I'm going to stop there for you guys to take screenshots. I'm also going to stop, and if anyone has a question at this point, now is the time to raise your hand. Otherwise, you're going to try one by yourselves. Okay, guys, and please don't feel shy to raise hands and ask questions. This is a very important section, so please do ask. Vele, a question?
Ma'am, I would like to ask, why don't you need to show a positive sign in front of the number?
Okay, so good question. If it is the first number or the first term that we're writing down of our expression, we only need to put a sign there if it's negative. But if it is a positive term, then we don't need to write down a positive. If, however, we had 2 terms, so let's say, for example, we had negative 3x plus 2y, because it's now the second term, we need to show that it's a separate term, and so we would put the plus. But if I wrote it the other way and said 2y minus 3x, I don't have to put the plus there. We leave off a plus, and we just always assume that if there's no sign in front, it is a plus.
Oh, okay, ma'am. Thank you.
Good. Okay, so guys, that's a good question. It's almost like the coefficient of 1, like you can see here. We never write a coefficient of 1, so we never write the 1 in front of our variables, but we know it's there. It's the same thing with exponents. If a number doesn't, or if a value doesn't have an exponent, we know there's an exponent of 1, we just don't write it. So it's similar with the plus sign. I hope I say your name correctly, Sinead.
Sorry. So does, like in question B, like, so the variable has an invisible exponent of 1. So if it's like vice versa, and you have a variable, does that also mean that the power to that variable is an invisible power of 1?
Yes. So if you had, for example, x times x squared, there is an exponent of 1 there, we just don't write it.
Okay, thank you.
Good, well done. Okay, so guys, that's exactly what I said now. If you've got if you've got a variable or even a number that has no exponent written with it, there is actually an exponent of 1, we don't write it. Same as there are actually coefficients of 1 here, we just don't write them down. So those are just things that you need to remember when working with your algebra. Right, grade 8, nicely done. So let's have a look here at question C. I'm gonna start you off and then we'll see. So guys, remember, as I've been saying over and over again, we always want to look for the same bases. So in question C, I've got an x and an x, so English, I've got x cubed times x, and this goes back to what Sinead just said. There is actually an exponent of 1 here, we just don't write it. And those bases are the same. Completely separate to that, but still in the same sum, we have also got the base y. So we've got a y squared times a y squared. And we did actually do an example of this right at the start of the lesson. So I want you guys to try and simplify for me. X cubed times x times y squared times y squared. Now remember, you can only add exponents when the bases are the same. So I'm going to put a little note here for ourselves. Remember, guys, once you have an answer, you can put it on the chat for us so we can have a see. Again, grade 8, please, please, please remember that you can only add exponents when the bases are the same. That is very, very important. If you just start adding things left, right, and center, you are not applying your laws of exponents. Okay, good. I'm liking that. I'm getting an answer or two coming through. Guys, just sorry, like it really isn't important because I know what you mean. Just on the chat, if you want to show an exponent anytime, if you hold down Shift and 6, you will see that you get a little like hat button. So you could type X Shift 6, so Shift and then 6, and then you would write your exponent, and that means X to the power 4. So on the chat, you can do that. I'll type it in there so you can see what it looks like. That then means X to the power 4. Right, just that when you are typing your answers, you can show that you've got an exponent there. Otherwise, we're talking about coefficients, and those are two different things. Now, guys, remember, you started off with variables, so your answer should have variables in it. We're not canceling anything, we're multiplying values here. So you should end up with variables in your answer. Righty, does anyone want to raise their hand to explain how they did this? Tandawake, tell us.
Okay, ma'am. So what I did, ma'am, also I just said also for the x times the x just gives you the simplest, which is also x. And then what I did, I add the 3 and plus the 1, it gave me 4.
Good.
Okay.
And the y's?
Okay, and then for the y's, I said y times the y just gives you the y, just give the same base. And then what I did, I add the 2 plus the 2 plus the 2 gives me 4.
Excellent, well done. Nice, Tandawake, very nice. Okay, guys, so exactly that. For the x's, you've got an exponent of 3 and 1. You need to add those. For the y's, you've got an exponent of 2 and 2. You need to add them. And so 3 plus 1 is 4. 2 plus 2 is 4. And so you get a final simplified expression of x to the power 4, y to the power 4. Now remember to write them up at the top for the exponent. They're exponents, they're not coefficients. And remember, guys, you're not going to get 8 because you cannot add together the 3, the 1, the 2, and the 2. You have got different bases here, so you need to keep them separate. The x's stay with the x's, the y's stay with the y's. Remember when we did our algebra course, for those of you that were with me for the algebra course, we spoke about the fact that when you have different letters, you are representing different values. So x and y represent different numbers. And so we can't just put them together because they don't represent the same thing. If they did, then we could put them together, but we don't know that. And so we need to keep them separate. All right, I still see 2 hands. Nelson and Vele, your hands are up. If these are questions, you can leave them up. And for anyone else, if you have questions, you're welcome to raise your hand. I'm going to leave this here in case anyone wants to screenshot. Nelson?
Yes, can't the answer be 8? Because you first said that you have to add the exponents.
Mm-hmm.
I did 4 plus 4, which gave me 8. So couldn't that be the answer?
Okay, I've just explained why it can't be. So because the bases are different, because you've got x and y, we can't add them all together. They are different variables or they're different letters. So we can't add the x's and the y's exponents.
Okay.
Righty, guys, I'm hoping you've got your screenshots. It's been a lot of information, so I think it's time for a little brain break before we carry on with some more examples. All righty.
Great. They did a really good work, my people. Well done, guys. We deserve a brain break now.
Definitely.
More time.
Oh, sorry, guys. All
We're in
righty.
the same boat.
Yeah, jeez. Alrighty, guys, so here's your brain break. You've got your joke there. I will make the brain break bigger so that you can see the pictures quite clearly. Just quickly, must say clear. It's not x to the power 3 because remember, this x has an exponent of 1. So that 1 we need to add as well. Just because we don't write it there doesn't mean it isn't there. So there is still an exponent of 1 there. All right, guys, there's your brain break. So the reason I want to make it bigger is that you can see very clearly where there's 2 and where there's 1 of each of the books. So just that you can see, these are 2 books. Here we've got 2 piles of books, whereas here's just 1 pile of books. And here in the yellow, you've got 2 books, whereas here's just 1 book. So just be very careful of where you've got 2s and where you've got 1s. And we want to know essentially what the very, very final last value is here. Oh, that's a bit excessive. Let's do that again. So this very final equation, what is the value of that final equation over there? Remember your BODMAS. If you're not going to use BODMAS, you're going to get some very strange answers. And we know that BODMAS is important in order for us to get the correct answers. Tandawake, very nicely done. So guys, you can see on the chat there, Tandawake has helped you for the first step. Well done. So we can see here, I'm not going to do all of it, but just so we all know, these double blue books represent a value of 14, because 14 plus 14 plus 14 is 42. So hopefully that's going to help you for the rest. Keep it going. On the lookout for the right answer. Haven't seen any yet. If we don't get it, we'll just carry it over to not next week, to Wednesday. But like I said, Tandawaki has helped you there, so hopefully that is helping you in the next one. Guys, I hope we're trying. When we get to equations, being able to do these is going to be very, very useful to you. So guys, just remember, for the second one, because you know these two books are 14, it does mean that these two blue books, they are also 14. So just bear that in mind. Tandawake, close, just remember these two books here, because they are the same thing, these values have to be the same. It's both double piles of books. They need to be the same value. Nelson, do you have a question?
Yes, it could be 1 plus 14 times 15
For which one?
for number 2.
Okay, say it
second one.
again. Yeah, say it again for me. It could be.
1 plus 14 times 15.
Okay, so just remember, like I say, because these pictures, let me just do this. Because this picture and this picture are identical, the numbers must be the same. So if this is 1, that will be 1 as well. If that's 15, that will have to be 15 as well, because they're the same picture. So they represent the same number. Good try though, well done. And guys, this is what we need to be thinking about. This is exactly as Nelson said, like what numbers can I put into these sums in order to get the correct answer? I'll tell you now, guys, there's never any decimals or fractions in these ones. If there ever is, I would warn you, but here there's no decimals or fractions. Okay, I think I'm going to give you another minute.
Yeah, otherwise it's gonna be a homework.
Yeah, we're going to take screenshots and then you're going to try and we'll see what happens on Wednesday.
Yeah, I think we can give it a homework. I'm even wondering why no one has got it yet. Hey, my people, it means that this algebra will really help us a lot. Hey guys, this exponent, hopefully. Yeah, but we did algebra, didn't we, teacher Sam?
We have done algebra, yeah?
Oh, guys, this is a good practice to actually do these things. Then it will be best as a homework because no one got it right yet.
Yeah. Okay, so I think homework, I'm just going to say well done to Yonga for putting in another little hint for us on the chat there. So I would take Yonga's hint and I would give this a try and we will see. Oh, as we're saying this. Andile, well done. Andile, do you want to raise your hand and explain to us how you got 107? There we go. Andile?
Ma'am, I said 7 plus 20 is 27. Times 5 is equal to 107.
Good. Okay, guys, so let's just make sure we all know why that is. So I'm going to go back to Yonga's statement there. In our second step, we've got 10 plus 14 times 10. Now just remember BODMAS. So we have to do the times first. So 14 times 10 is 140, plus 10 gives me 150. Now, if the double pile of books is 10, that means one pile of these books is 5. And so in my second step, excuse me for turning like this, I've done something to my neck, but anyways, in our second step, we've got 10 times 10 plus 5. Again, BODMAS tells me to do the times first. 10 times 10 is 100, plus 5 is 105. And so this is now why Andile said 7, because from the blue books, two blue books is 14. So one blue book is 7. One yellow book is 10. So 2 yellow books is 20. And we already know the pile of books is 5. Again, we do BODMAS. So 20 times 5 is 100. Whoops, sorry. Is 100. And 100 plus 7 is 107 as our answer. So Andile, very nicely done. And guys, just remember BODMAS. If you don't do BODMAS, you're going to get some weird answers. So Andile remembered BODMAS there, and this is why we're getting 107 as our answer. Well done, guys. Alrighty. So again, I know this might seem like something you don't want to try, but I can't stress enough that as much as this is something fun to do, when it comes to solving equations, understanding how to do these sorts of brain breaks is going to help you immensely. I can't even tell you, even just for myself, since doing these sorts of brain breaks, it has helped me so much to understand numbers better in terms of how they work with each other. And so for me, solving equations has actually become a whole lot easier because of our brain breaks that we do, just by seeing how numbers work together. So I can't stress enough how important it is to try these things. And you don't have to get the answer, but you have to try, because if we're not going to try, we're not going to go anywhere. Alrighty, guys. So let's have a look at some more exponent examples. So we finished off at C. Let's have a look at question D here. Now, once again, we need to remember SNV when doing these sorts of questions. So signs, numbers, variables, and we just work left to right. There's no need to try and overcomplicate. There's no need to try and do everything at once. Obviously, as you gain confidence, if you look at this and you say, okay, I know what my answer is, and you write down your answer, that's fine. But there is no need to do it all in one go and make silly mistakes. So we're going to start with the signs part of our SNV. So when it comes to signs, I can see that I've got a negative times a negative. Now we know that a negative times a negative gives me a positive answer. So I know that the answer that I'm going to get from this product is positive. Now, if we go back to, I think it was Vele's question, we don't write the positive there. If it's the first thing after the equal sign, we don't write down positive. We just know that it's positive. But we need to have done the signs part of SNV in our heads to make sure that we know what the correct sign is. So once I've done my signs, I move on to N, which is the numbers. Right, so if I have a look at my numbers here, I've got 2 times 3. We've already dealt with the negative, so I don't need to stress about that. But now when it comes to my numbers, I've got 2 times 3. Now we know that the product of 2 times 3 is 6. And so we write down our 6 next to our equal sign. We know it's a positive 6. We just don't write the plus there, but we've got our 6. Then finally, we deal with our variables. Now, the variables here, what you need to do is you need to make sure you've got the same bases. So here I've got a base of x, a base of x. That's all good. I can add my exponents. And so what I'm doing here is I'm saying x squared times x cubed. And we know according to our law, that means I can add the exponents 2 and 3 together. So I will have 6x to the power 2 plus 3. And so my final simplified answer is 6x to the power 5. By applying my exponent law, by applying the fact that I can add the exponents when the bases are the same, I've been able to simplify my expression. So again, grade 8's SNV, so useful to us. Again, as you gain confidence and as you become more comfortable with this stuff, some of you will be able to look at this and say, cool, I know it's 6x to the power 5. But until you gain that confidence, do it step by step. Don't rush it. There is no need to rush it. Do it step by step. Make sure you're getting it correct. All right, so I want you guys to try question E. Use SNV. Remember that your bases must be the same in order for you to add exponents. So this is a bit similar to question C, because now we've got the bases of x and a base of y. So we need to keep those separate. We can't just add the exponents as we want. So give it a try. Remember, put your answers in the chat once you've got one. And remember SNV, very helpful. Okay, so I'm just going to remind you, signs, numbers, variables. If you do it step by step, you should get the right answer. And remember, guys, if your answer is going to be negative, then we do need to write the negative sign. If it's positive, we don't need to. Okay, I'm seeing some answers starting to come in. Very nice. Keep them coming. Well done on remembering your little hat thing there. So remember, anytime you want to have an exponent, you put the little shift 6, so x to the power, I don't know, whatever, 2, y to the power 3, z to the power, whatever. Every time there's a little hat, like I've put on the chat there, it means that the number after the arrow is the exponent. So you can have it for multiple variables. That's absolutely fine. Check your signs, guys. A negative times a negative times another negative. We've got 3 negatives there. So should your answer be positive or should it be negative? Good, Nelson. Well done. I'm going to give everyone another minute or so. Right, would anyone like to raise their hand to explain it for us? Okay, Vele, do you want to explain it for us?
Sorry, ma'am. I think the answer is -7x to the power of 2y to the power of 3.
Okay, where did you get -7 from? Let's start with that.
What I did first, I thought of the sign. The positive times positive is a negative, but then the one I meant positive times negative times negative is a positive. Positive times a negative is a negative. So
Okay.
that's where I got my answer of that. My answer will be a negative.
Good.
So then I said 2x plus 3xy. So my answer was 5xy, 5x to the power of 2y.
Okay, so we're on the right track, which is really good. Just remember, if we're doing SNV, so we've done our signs like you correctly told us, but when it gets to the numbers, we want to multiply the numbers. So now I want to take these big numbers here and I want to times them all together. So what I actually want to say here is 2 times 3 times 2. So 2 times 3 is 6, and 6 times 2 gives me 12. So we've got a -12, and then I deal separately with my variables. And now when I get to my variables, I've got the x's, so x times x squared, which means that when I add all of these exponents, remember the x's that have no exponents do actually have exponents of 1. I've got x to the power 1 plus 1 plus 2. And then separately, I do my y's because they're different variables. Now I've got y times y cubed. This y again has an exponent of 1. So I've got 1 plus 3. So I need to just remember that these coefficients, the numbers I've circled in pink, need to be multiplied together. And so we end up with -12 x to the power 4, because 1 plus 1 is 2 plus 2 is 4, y to the power 1 plus 3, which is 4. So our final answer here, -12 x to the power 4, y to the power 4. So guys, just remember, you only add the exponents. I will come back to this, don't worry. Remember our rule that we wrote down is that we add the exponents. I said nothing about coefficients. We add the exponents. And so when we get to something like question E, we are adding all of the small little numbers at the top of my variables. Right, I'm going to let you take a screenshot here. You're going to see that a poll is going to pop up. Please make sure you do it before you leave.